This is the assignment for April 29th over 11.2, 27, 28, 11.3, 47, 48, 11.4, 5 and 6, 11.5, 17 and 18, and 11.6, 23 and 24. 11.4 I believe is 15 and 16. Excuse me. Okay, 11.2, 27 and 28 is using the quadratic formula. Make sure you get your equation equal to 0, like number 28. 2 equals negative 9x squared minus x. I moved the two terms to the left side because I like to have my first term positive. 9x squared plus x plus 2. Then I simply put them in my formula, and I got the square root of negative 71, so I have negative 1 plus or minus I square root of 71 over 18. 11.3, 47 and 48. When you have equations with fractions, first thing you need to do is factor any denominators. And I factored x squared minus 25, it's x minus 5, x plus 5. Then step 2, look at the domain. Okay, there's two numbers you can't ever put in for x because you'd be dividing by 0, 5 and negative 5. We may not need that, but we've got it in case we need it, because if we come up with those answers, we throw those answers out. Then, when you've got an equation with fractions, multiply by the common denominator, x plus 5, x minus 5, times every term. I stretched it out. You know, here's part of it, here's the second part, here's the third part down here. I canceled, all the denominators canceled out. So I have x times x plus 5 times x minus 5 equals 1. Then make sure you move everything to the left side and make it equal to 0, combine like terms. So we get x squared plus 10x minus 24 equals 0. Then you could either factor or use a quadratic formula. I went ahead and factored x plus 12, x minus 2. So x is negative 12 and 2. Then 11.4, 15 and 16. Okay, it's 5 over y plus 1, over the whole thing, y plus 1. May be written out like this. It's greater than 0. The next one, 3 over y minus 5. Remember, on these inequalities less than 0, set the numerator equal to 0, set the denominator equal to 0. Well, 3 can't equal 0, so we don't get anything out of the numerator. We set y minus 5 equal to 0, we get 5. Then, that's the only number we have, so we divide the number line up. The number line goes from negative infinity up to 5, that's one separation, and from 5 to infinity. Is it this one, is it this one, or is it both of them? Well, to find out if this interval works, take any number in it. I tried the number 3 by putting it into the original equation. 3 over 3 minus 5 gave me 3 over negative 2. That's a negative number. That is less than 0. So this first interval did work. Then I tried the second one. I take any number between 5 and infinity. I tried 6. 3 over 6 minus 5 is 3 over 1. 3 is not less than 0, so it did not work. So the only one that worked was negative infinity to 5. Then 11.5, we have parabolas in standard form. In other words, number 5 I did not do anything with. All this work down here is for number 18. You can see the x-coordinate of the vertex by looking at the equation. It's from here. X plus 4 is squared. So I set x plus 4 equal to 0. So my x is negative 4. Then that's my negative 4, my x-coordinate of my vertex. I put it back in for my x up here. Negative 4 plus 4 squared minus 6, like I've shown here, comes out to negative 6. That is the most important point. You've got to have that point there. That is the vertex, the bottom of it, where it turns. Then I went on each side of the -4, -3 and -5. I put those in the equation and worked it out, -5. Then I went out a little bit farther. Then I went 2 to the right, -2. Then I went 2 to the left, -6. Put those in the equation, came up with -2. I plotted those points over here, these ordered pairs right here. There's 5 ordered pairs. Then I looked at my graph, and I didn't find exactly what the x-intercepts were, but there are 2 of them. It crossed the x-axis twice, so 2 x-intercepts. Then my y-intercept, I put 0 in for x, and I got -1. My domain is my x's. Look back at the equation. There's no x's in the denominator. There's no radicals. So you can put all numbers in for the x's, from -infinity to infinity. Now the range, though, you've got to look at the graph. What's the lowest y-coordinate? -6 to infinity. Okay, that's parabolas in standard form. The next one is a parabola in what we call general form. We've got 23 here is this equation, x squared plus 4x minus 5. You do it just like I did 24, x squared plus 2x minus 3. We always start out with the vertex. We don't have any parentheses, so this is called general form. So what I do to find the vertex, the x of the vertex, is take -b over 2a, -2 over 2 times 1, so -2 over 2. So -1 is my x-coordinate. Then I put that x-coordinate into my equation for all of my x's here, right here, and I come up with -4. Again, now it goes just like the other parabolas. I go 1 to the left, 1 to the right, -2 and 0, or 1 to the left and 1 to the right of -1. I put those in my equation, find out they come out to -3. Then I go 2 to the left, -3, and 2 to the right, 1. Put those in my equation, they come out to 0. Then I plot those points. Remember that vertex, the first one's very important, it's where it turns. My x-intercept on these in general form, you put it equal to 0. You're either going to factor it or the quadratic formula to find, either factor it or the quadratic formula to find the x-intercepts. Then you put 0 in for the x to find the y-intercept. And then remember the domain. The domain, no x's in the denominator and no radicals, so all real numbers. The range, again, look at your graph. The lowest y-coordinate is -4. So that is my range. And this is my domain. Then I went to composite functions on 12.1, 17, and 18. Here's what you do. We've got the 2 functions. X plus 10 is one, and 3x plus 1 is the other one. To find f composite of g, whenever your g is the second number, you take whatever g is, 3x plus 1, and put it in for the x. 3x plus 1 replaces the x, so it's 3x plus 1 plus 10 is 3x plus 11. Then when I find a composite function of g composite of f of x, I put the f one, x plus 10, in for the x right here. The second one here, I put x plus 10 in for the x here. 3 times x plus 10 in parentheses plus 1, so 3x plus 30 plus 1 is 3x plus 31. Then I go to writing my inverses on 12.2, 29 through 30. Same steps as before. You've got your function. You put y in for the f of x, so that's all it changes on the first step. Then you switch x and y around. Then step 3, you solve for your y. To solve for our y, first thing we had to do is add 1 to both sides. Then I had to take the cube root of both sides to find it. So that's number 30 there. Then 32, the instructions in the book may be slightly different, but we're doing the same thing. F of x equals 6x minus 1. Put y in for f of x. Then switch x and y around. And then we do the work to get the y by itself. First we add 1, so x plus 1 equals 6y. Then we divide by 6. X plus 1 over 6. X plus 1 over 6. Then on 12.5, we start doing our logs here. Notice the work there, like 34. Log to the base 2 of 1 over 32 equals x. So 2 to the x equals 1 over 32. What you need to try to do is get both sides to base 2 if we can on this. 2 to the x equals 1 over 2 to the 5th. And 2 to the x, we move that 2 that was in the denominator to the numerator. So 2 to the x equals 2 to the negative 5th. Then 35, 36, done the same way. 37 and 38, done the same way. 39 and 40, done the same way. Change them from log to exponent form, and then get the base, like on 40 here. Log to the base 10 of 1/10 equals x, so 10 to the x equals 1/10. What we need to do is we've got 10 in the numerator here, move this 10 to the numerator, it becomes 10 to the negative first. So x equals negative 1. 42, log to the base 2 of 16 equals x, so 2 to the x equals 16, and you'd get both sides to the same base. 2 to the x equals 2 to the 4th, so x equals 4. Okay, 44, same way. 3, log to the base 3 of 1/9 equals x, so 3 to the x equals 1/9. Get them both to the same base. 3 to the x equals 1 over 3 squared. Move that 3 up. Okay. The last lesson we have here. Okay, here's 45 and 46. Same thing. On 47 and 48, same kind of thing. We're solving them. Look at 46. Log to the base 4 of 64 equals x. So it's 4 to the x equals 64. So 4 to the x equals, we change 64 to 4 cubed, so then x equals 3. And then number 48, log to the base 2 of x equals 3, so 2 cubed equals x. X is by itself, so 8 is our answer. Then 12.6, the three main rules of logarithms are the same as exponents. If you are adding logs like here, log to the base 3 of 8 plus log to the base 3 of 4, since both of those you're adding logs, you're adding exponents then, so you could multiply 8 times 4, 32. Same way on number 4. You're adding logs, so we can put them together, multiplying. Number 6, we're adding logs, so we can put them together, multiplying. Y cubed times y minus 7, or y to the 4th minus 7y cubed. What do you do when you're subtracting? Log to the base 7 of 20 minus log to the base 7 of 4. You divide 20 by 4, which is 5. And that's what I did on these three questions. I divided. Then, what do you do when you have an exponent? Log to the base 2 of x to the 5th. That 5 can either be there as the exponent, or you can move it out in front, 5 times the log. Same way on 20. Negative 2 can be the exponent or out in front. And then here, number 22, remember, log to the base 5 of the cube root of x. Remember, that's log to the base 5 of x to the 1/3, and then that x to the 1/3 can move out front. 1/3 log to the base 5 of x.